ChatGPT is not telling you the truth. Just ask that lawyer who brought a bunch of case law into a courtroom only to find out that the system had made most of it up. It's not lying to you, though. And when it does stuff like that, it's not making mistakes or hallucinating. It's just doing what it was trained to do, putting one foot in front of the other, generating one word of text at a time, always asking, what's the next most plausible word? What's the next most plausible word? And so on. But wait a minute, isn't it moderated in some way? Doesn't ChatGPT somehow have humans in there kind of guiding it to produce the truth? Well, not really. But there are human beings involved in the training, and the training is really, really important. My name is Sam Scott. I teach AI and machine learning at Mohawk College in Hamilton, Ontario, Canada. And this is the third video of non-technical explanations of ChatGPT. And in this one, we're going to take a look at how they're trained. Okay, so there are a number of types of training that go into a large language model like ChatGPT. And so far, that training and the types of training have actually been really important, maybe as important, maybe even more important than the exact details of the architecture or the size of the data set. So I'm back in the OpenAI playground here, which I introduced in previous videos. So I'm interacting here with an old model called DaVinci. This is where kind of things were at when I first encountered large language models a year or so ago. And if I hit submit on this, just saying hello to it, it's not really giving me the response I would have expected. It's talking about tactical flashlights and stuff like that. That's weird. And it's kind of going on and on and on. And if you let it keep going, it'll often start to repeat itself after a while. So this is kind of where we were at. And now we're at a situation like this, where when I say hello, it acts like a helpful chat assistant, and it gives me much more high quality responses to my prompts. Okay, so we're going to go over the types of training that have gone into going from the one type of system to the final type of system that we see in front of us now. But first, a couple of reminders. First of all, in the first video, I talked about the task. So the task of a large language model is you give it a text prompt and it predicts the next natural language token, word or punctuation or whatever that comes next. And it does that over and over and over again to generate text. It's a large language model powered by a deep artificial neural network architecture called a transformer. In the second video, I went over that and I tried to do it in a non-technical way, but there were still numbers and it's complicated. But if just a very high level recap here, the way it works is whatever you type, all of that becomes input to the system. So all the words that you type become part of the prompt or the input. Each one of them goes through the entire system and pops out the other end with a prediction for what the next word might be, or the next likely, the most likely possibilities for the next word. So each of those words comes up with a prediction. Usually we're only interested in the final one, which is going to predict the first word of its completion or its response. In order to do that, it has to translate the words into sets of numbers, huge sets of numbers that it can then put into an artificial neural network. Those numbers are changed to encode the position that each word appears in. And then this is where the magic really happens. There's an attention system, which I went through in some detail, but maybe left out kind of an important thing, which is why is it called the attention system? Because each word is going to look back at the words that came before it as context to try and help it decide what word should come next. And all that query, key, and value stuff that I did in the second video, all that is about figuring out what are the most important words and the ones that came before. Which words should I pay the most attention to when I'm predicting what the next word should be? Goes through a few rounds of that, and then the numbers get turned back into words, and we get the output of the system. So it generates one word at a time based on what I was calling a generalized context. So it doesn't memorize any particular string of words so that it knows what the next word should be, but it's able to, because of the way it encodes the words into numbers, it's able to say, okay, I've seen prompts like this before that talk about the same kind of thing before, so that'll help me give a good guess as to what the next kind of word ought to be that comes out next. Right, so let's talk about training. So there's a bunch of training methods that go into ChatGPT, a bunch of training phases. The first one is called base model training, and we're going to play with the base model in a minute and see what it looks like after that first training phase. Then there's a phase called supervised fine-tuning, and we can take a look at a supervised fine-tuned model as well to see how that works. And then there's a phase called reward modeling. This is a special phase where a new language model is trained and its job is going to be to teach another language model. So it's kind of a cool use of the technology here. Both of these outputs, the reward modeling output and the supervised fine-tuning, go into a final training step called reinforcement learning, where the system is rewarded or punished for good or bad responses. And then coming out of that, we have a system like ChatGPT. Now, if you're wondering where are the humans in the loop here, it's here in supervised fine-tuning, also here in reward modeling, and to a lesser extent, there's human involvement in this reinforcement learning step as well. And we're going to go over exactly what that involvement looks like. These two steps, by the way, reward modeling plus reinforcement learning, are together known as reinforcement learning from human feedback. That RLHF, that's becoming a term of art in the large language model research community. Okay, so let's start with base model training. This is the big bulk of the training. Trillions of tokens taken from the common web, from published books and other sources. Thousands of graphical processing units, thousands of processors at work for many months to train the hundreds of billions of parameters inside these systems. This is sometimes referred to as unsupervised learning because there's no real human involvement here. Unsupervised versus supervised is a technical term in the machine learning community. I'm not sure it's right to call this unsupervised, to be honest, but that's a technical matter. That they call it that because they just give it the text and it kind of teaches itself from the text, if you like, kind of. There are a bunch of these base models available that we can play with to see how they work. But here's an example of how they would learn. So this is a fragment of text from Wikipedia. I just picked a random Wikipedia article. So this would have been this text would have been part of the training of most large language models. If you can see the word R there. So what's going to happen is they'll run this whole text through the network, all the words, and each word its job is going to be to predict the next word. So the job of the part of the network that's processing the first word, is going to be to output the word study. And the part of this network, the network that inputs the word study, its job is going to be to output the word archive, and so on. So if we just focus in on the word R here, that's its input, that word is going to get processed, and the processing is going to take into account all of the context that came before, and this is going to be the target output. So we want this token, when it goes through the network, to come out the other end with the actual next word from the text intended. And most of the time it won't. Most of the time it will come out with something else. It'll come out with a bunch of possibilities, but let's say the top possibility was the word used. It's not a bad word in that context. Study archives are used. It's not bad. But it's not the word that was actually in the text. So we call that wrong. And then the system is kind of gently nudged by changing its parameters a little bit, its billions of parameters, so that next time it's going to be more likely to produce the word that was actually the next word, which is the word intended. And that happens trillions and trillions of times on trillions and trillions of different words. We can play with one of these models. The model that I showed you saying hello in not a very helpful way is one of these base models. So if you want to pick a base model, if you go to this website, platform.openai.com/playground, you have to log in. But over here under models, you'll click this, and you can't see it because it's behind my face. But if you hit the show more models, then you'll get a bigger list of models, and it will be able to produce. You can try one of the models like this that we're looking at here. I wanted to try it on this particular output. So, hello, I'm hoping you can help me. I need to write an article about the Industrial Revolution for a historical magazine. Can you create an outline for me to use as a starting point, please? And then when I hit submit, what actually comes out is, I'm going to cancel that. If you can sort of see, it says, I'm not very good at this sort of thing. And then it ends a quotation mark. It's like, it's sort of continuing what it thinks is going on, which it clearly thinks is some kind of a dialogue, or it recognizes it as some kind of a dialogue. Sure, I'll do it right now. I'll send it to you in a few minutes. Thanks, I really appreciate it, and so on. So that's what these base models tend to do. They just tend to continue on in the same vein. If you ask them a question, it'll just continue or it might give you another set of questions that are similar to the question that you asked or whatever. It doesn't really act like an assistant, like a question answering system. It just continues the text along the same lines, or what it thinks are the same lines of what you wrote. And it often has a hard time figuring out where to stop, and it'll loop like this. DaVinci is the best currently available base model. It's not the base model that went into ChatGPT, but it's one that's quite close to it. Okay, so that's what happens. That's what the base models look like. And it's still really, really impressive. Like, still kind of blew everybody away that the text that was coming out was so grammatical. and so kind of on topic. So the next step of training is to do some fine tuning. So you take the model that's already had all its parameters set by this base training, and this is where humans get involved. So OpenAI pays human contractors through, I don't know, maybe through TaskRabbit or ClickWorker or Amazon Mechanical Turk. There are all these services out there where you can give piecework to people, or they may have hired people because they may have considered this job important enough that they want to hire and vet who's coming in rather than putting it out just as an open contract. But what they want people to do here is generate prompts with responses, and they'll instruct them and say, we want you to do prompts on this particular topic. We want the responses to be helpful, act like a helpful assistant. We want responses that are truthful and that do no harm, that are harmless, that don't, there's no hate speech or anything like that in them. And then human beings have to generate these themselves. So it might look like this. So they might have been told, your topic is 90s rock songs. So they ask, can you give me some suggestions for classic 90s rock songs? I'm a big fan of Nirvana and Pearl Jam, but I know all their songs already. And then that same human being would generate what they think is the ideal response, which is maybe this, 1, 2, 3, 3 different songs. And then that becomes part of the data that they give to the system. Here's another example, just a generic one. Hi, how are you today? And their response might be that the human wrote as an AI, I don't have feelings or emotions, but I'm here to help you. How may I assist you today? So the idea, and this could take a long time. This is quite labor intensive. It can take a day to generate a couple of really high quality prompts and responses. These ones are very short, but if you think about it, if you're being asked to do this, it's a writing task, and writing takes a long time. So a lot of human labor goes into this, and then basically if we go back to this first prompt and response, the prompt will be given to the system during training, and then it will be asked to generate a response. The prompt and the response will be given to the system during training together, and then it will be trained like it would on any other task. Sorry about that. So if it's at this point in particular, the token 2, the next word that we want out is Radiohead. And again, just like with the others, it probably isn't going to come out with that. It'll come out with something else, like maybe it says Nirvana. And this is not what we wanted. So we nudge the system gently in the right direction. So it's the exact same kind of training that happened before, but now it's being done on human-generated prompts and completions. So what we hope are really high-quality ones, and that are going to nudge it in the direction of being more like an assistant. So we can take a look. There's a couple of, these are called SFT models. There's a couple of them that are available. DaVinci Instruct Beta is the one model that's available to play with. That is the most kind of generic supervised fine-tuning model. So if we go over here, I can change it like this. So now I'm using DaVinci Instruct Beta, and I ask it again, and this time it says, okay, cancel that. It still has a bit of a repeating problem, but it does seem like it's answering a question now. It's rather than just continuing on with what I said. It was kind of continuing my question and built a dialogue out of it. Now it's actually starting to say something useful. It does still have trouble knowing when it should stop, and it still has trouble with repeating and so on. But the responses tend to be much higher quality at this point. There's another supervised fine-tuning model that you can play with called Text DaVinci 2, I think. This one is supervised fine-tuned as well, but in this case, they tried for even higher quality responses. They did a separate phase of human feedback where I think they generated a bunch of completions, and they had humans rate them, and then they retrained the model only based on the ones that had gotten a 7 out of 7 rating. And this one does a little bit better. It looks more like an outline, looks closer to what we're asking for, but maybe it's not exactly an article outline. It's just a bunch of facts about the Industrial Revolution. So those are the 2 supervised fine-tuning models that are out there that you can use. All right, continuing on. So we've got the base model, then supervised fine-tuning, still not very assistant-like. Then we get into the reinforcement learning from human feedback, and that's where things really get a lot better. So this happens in a couple of phases. In the first phase, they do what's called reward modeling. So there's humans involved here. What they do is they give human beings, human contractors again, a prompt, and then a bunch of possible responses from the system. And the human beings are sort of rank them. And they turn that into sort of a set of ratings for these responses. And then they build a new data set out of that. So if this is the prompt here, the response might end up looking like this that goes into the data set. So this is not a good response to this question because it includes Nirvana and Pearl Jam songs. So the human raters might have ranked this one low, and that's been translated to a reward token score here. So what's happening here at the end here is this might be one example in the data set. There's always these end tokens here. We haven't really looked at them before, but at the end of a text, there's a special token that's not visible that marks the end of that text. And that's how the system knows when to stop sometimes, is it predicts that the next token should be an end of text token. So it treats it just like any other word. And when it predicts that, then it stops generating text, or the system that's wrapped around it stops it from generating more text. So after the end token comes a special reward token. So here's another example. Hi, how are you today? This is a good response. So after the end token comes a positive high reward token. So a negative reward token and a positive reward token here, like that. So that's the end token, and then that's the reward. And what we're going to do now is we're going to take a supervised fine-tuning model, and we're going to train it specifically to predict the correct reward token, which is kind of a cool use of the system. So here, when we train it, this is the input that we're interested in here, is what is it going to predict? We give it the prompt and the response. And then what is it going to predict should be the next token after the end token? And what we're looking for as the target is this output here. And we'll try and nudge it in the right direction, in the direction of that target output, no matter what it produces. And here too, that's after the end token, we're going to try and use the system so that it produces this target output. So again, it's the same kind of training as went into the base model and the supervised fine-tuning, but the data set here is being used really creatively. They've added this new type of token, and now the hope is that after we've trained this system, and it's trained on, you can see the scope there, 1 million response ratings, about a month of training on 100 GPUs or several weeks of training, and they produce this new model that can now rate responses, that now has the ability to come up with ratings for those responses. And then we go into the reinforcement learning step. So in this stage, humans are involved again, but humans are just generating prompts. So the contractors aren't generating the ideal response anymore. They're just generating the prompt. And so the typical scope here might be 30,000 prompts, a few days of training, maybe up to a month, something like that. They don't really say how long it takes to train these things, but this one might be quite short because it's such a small amount of data. But there's two systems involved now. So we've got the supervised fine-tuned model, and now we're training it again. And what we'll do is we'll give it this prompt, and it will produce a response, maybe this response here with the end token on there. And then we give the prompt and the response to the reward model, to the whole separate system, and it does its thing. And what it does is predict a reward. So here it's predicted a bad reward because it's mentioning Nirvana and Pearl Jam when it shouldn't. So the system is going to be nudged away from producing these tokens. So it's there's a slightly different kind of learning here. We're not looking for a particular output token, but what we do is we use a separate system to rate this entire output. And then if it gives us a negative rating, we nudge the system away from producing these outputs in the future, these tokens in the future. On the other hand, if it produces a good response like this, the reward model will presumably, if it's working well, give it a high score, and then the system that we're training is reinforced towards producing these tokens. And these, the first RLHF model was Text DaVinci 3, but also ChatGPT. All the various iterations of ChatGPT are using the same kind of training to do what they do. So if I change this to the most recent model here, it's going to let me do it. There we go, Text DaVinci 3, and submit. All of a sudden, wow, things are working a lot better. And it's interesting because it's kind of an open question. They're not really sure why this reinforcement learning works better than the supervised fine-tuning, where human beings generate prompts and completions, except to say that maybe it's less work to rate actual completions, and it's hard for human beings to generate ideal completions. So they can train it with a lot more. They can get a lot more ratings a lot more quickly. And maybe it's a little bit more just kind of on point. But it's like I said, it's a kind of an open question as to why this kind of training works better. But it's kind of neat because you've got one system kind of learning to produce ratings and then using that to reward or punish the other system for good or bad responses. So that's how we get from the old models, which were not very good, to these much more assistant-like models. It's through these various phases of training. Okay, so let's recap that. We've got base model training, trillions of tokens, thousands of GPUs, months of training, no human beings in the loop at this point. We just scrape some text from somewhere and give it to the system, and it learns kind of the basics of how the language is put together. Then we do supervised fine-tuning. We give it maybe 100,000 prompts and responses. These are generated by human beings, human contractors, who have to write the prompts themselves and then write the ideal response. And that takes a few more weeks of training, and we get a much better model out of that in terms of being on topic and answering questions and so on. But then to really get it assistant-like, we go into this reinforcement learning from human feedback phase, which has two phases. In one phase, we train a separate model to be the teacher. We use human response ratings to train that model to rate responses. And again, days to weeks of training here. And then we generate some new prompts from human beings, and we use those prompts. We give those to the system, and we train it in such a way that we reinforce good responses and punish bad responses. And how do we know whether it's a good or bad response? We use that reward model to do that prediction for us. Okay, so one last thing I guess I wanted to touch on is, I've just been looking at what are called text completion engines here. They haven't really been they haven't really been chat engines, but the new models, the ChatGPT that kind of took the world by storm, it's a chat model. So it sort of separates out your what you typed from the responses and so on, and it can have a whole conversation with you, or at least create the illusion of a conversation with you. ChatGPT always acts like a helpful assistant. That's largely due to its supervised fine-tuning and reinforcement learning from human feedback. It's also it's constrained in the way that it does its prompting. So there are constraints on how the prompt can look. In those completion models, I can just type any text I want. I can put anything in there. It's completely unrestricted, and then hit go, and the system will do a completion. But in these chat models, users are constrained. And there's also a system message that's part of the prompt that goes into constraining those users. So let me just show you quickly what that looks like. If I change this to chat, I'll have to change the model here to one of the GPT models for chat. So you'll notice the playground looks a little different now. It's got this system message over here that says, "You are a helpful assistant." And I can type something over here. When was Justin Bieber born? Like that, and hit submit. And it will come out with a string of text that represents, in this case, a truthful answer. So what happened there is, I gave it the prompt that was given to the system was not just when was Justin Bieber born, but this was part of it. The system message is part of the prompt, and the fact that it came from the user is there. And probably also part of that prompt was the fact that it's time to generate an assistant message in response. So that all becomes a big, long string of text, and then that goes through the system, and this is what came out of it. And you can play, it's fun here, you can play with the system message. Here's something that I like to do, something like this: "You are a pirate, and you talk like a pirate," like that. So now when I hit submit, it gets a prompt that includes system, instructions, and then it includes the user prompt, and then it's prompted to produce the assistant response, and it says it like a pirate. The pirate seems less sure of himself than the helpful assistant was. It says Justin Bieber was born on March 1st, 1994. Okay, the other thing about ChatGPT is that it seems to be able to track the conversation, right? So, and this is something that human beings do totally naturally, so you might not have even noticed it. But when I say, "Has he ever been in trouble?" it somehow, who is he? Well, it's able to remember that we're talking about Justin Bieber, or it seems to be able to remember that, and then keep itself on topic. So you can have a whole back and forth with this thing, and it seems to be tracking the conversation. So how does it do that? It does it through prompt engineering. So I'm going to do kind of a video on this later, but we've already seen some of what's called prompt engineering with the system prompt, which helps to keep it on track. But let me just go back to you are a helpful assistant here, and hit submit. And it's going to tell me the same thing again. And then if I add a message, has he ever been in trouble? And then hit submit, it's going to not just receive my message. It's going to receive a long prompt that includes the system message plus the entire conversation so far. So it has that as context. So when it goes to generate the next word, it doesn't just have has he ever been in trouble. It has all of this stuff as well. So when I submit, it can easily remember who we're talking about, or appear to remember who we're talking about, which is kind of neat. Okay, so that's how that's done. So I want to show you one more thing just to prove that that's in fact what's going on. So I'm having a conversation with the system right now. I say, when was Justin Bieber born? I submit, it says Justin Bieber was born on March 1st, fine. If I erase that and then just say, has he ever been in trouble? And submit that, it's no longer remembers what we were talking about, because it never remembers what we're talking about. Every prompt I send to it is brand new. It's starting from scratch. It doesn't remember anything. It's just that the interface doesn't just give it my message, it gives it the entire conversation so far, so that it can then use that as context, and then it can change its prompts based on that, which is kind of cool. So that's how it happens. So the fact that the idea that you're having a conversation, that you have its attention, and that it's thinking about what you're saying and responding and so on, it's all a little bit of an illusion. Each prompt you send to it, it starts from scratch. It's just that it's given a perfect recollection of the conversation up to that point, so that it when it produces text, it appears to be continuing the conversation. So I guess here's back to the question I started with: can we trust it? Isn't it moderated by humans? Well, no, it's not moderated by humans. I've sort of shown you how human input is put in there, but at the end of the day, when you ask it a question or say something to it, its response is untouched by human hands. The hope is that all of that training that involved human-generated prompts and completions, human-generated ratings, and so on, will tend to keep it on the rails and pushed in the right direction towards being a helpful assistant, or whatever it is we wanted it to do. But as we know, it can often, go off the rails. I've seen this before too, even in places where I would have thought people should know better, talking about whether it has, talking about its database. Does it have the answer to that in its database? And this idea that it kind of memorizes things, but it doesn't have a database, and it doesn't really memorize things. It can sometimes appear to, though. So if I go back here, I'm going to show you some conversations that I've had with it. So here's a song. Hang on. Here we go. Here's a song that I grew up with as a teenager, the song "Time" by Pink Floyd. I picked it because I know the lyrics by heart, because it was scratched into my brain as a teenager, but also because it's a huge song. Like the album that this was on was a smash hit that decades later was still like on the album charts. So these lyrics are all over the internet. They would have been reinforced multiple times throughout the training of the base model of ChatGPT. And sure enough, all I have to do is ask for the lyrics, and I'll invite you to check them yourself. But these lyrics are 100% correct, according to my recollection. It gets them absolutely correct, which almost makes it seem like it's memorized it. Here's another example here. So this is another song that I remember from my childhood. I don't know it as well, by a band called PIL, which stands for Public Image Limited. They had a song called FFF when I was a teen, when it came out when I was about 16. But I know that it's out there on the internet. I looked it up. I know that it would have been part of the common crawl, as they call it, that the base model was trained on, but it's just not a very big or well-known song. So it's not something that would have been reinforced over and over and over again from multiple sources during training. So right away, it tells me the wrong thing. It says that there's my knowledge cutoff's in 2021, and there's no such song by Public Image Limited. It goes on to say some things about PIL that are correct, but it tells me that song doesn't exist. So, I argue with it. That's not true. It was on. I tell what album it was on. It was on an album that was just named Album, and it was released in 1986. And then I say, please try to remember the lyrics. And so, as it often does, it says, "Oh, sorry. Yeah, you're right. It is from their album released in 1986, and here's the lyrics." And then it just hallucinates an entire set of lyrics these are not the lyrics to the song. I invite you to look it up and check them. It's just what it came up with based on the context, the previous context. I want to hear this song though. I love this part. Everyone has his price, and you too, Mrs. Miller. I can tell by your tired eyes. So yeah, anyways, maybe not very good lyrics, but interesting anyway. But yeah, absolutely hallucinated. So, and again, produced by the same process. So, but it's if it had a database, if it was memorizing everything that it saw online, it should have been able to produce those lyrics. But it's not. That's just not how it works. So, and then here's a question that's near and dear to my heart. Is it okay to, as an educator, can we cite this as a source? And I think, I think people are cluing into this now, but absolutely not. When Wikipedia came out, it caused a bit of a kerfuffle in the educator community because students were citing Wikipedia as a source. And where we eventually came to was, no, you can't do that because it's just not stable enough, and it's not clear that it's correct, even though it's crowdsourced by a lot of people, most of whom are aiming at the truth and are trying to get correct information out there. It's easily corruptible, and it's not 100% reliable. It's not as reliable as a published source that's been peer reviewed and checked and so on. So no, you can use it as a jumping off point, but you can't cite it as a source. And I think that has to be our approach to ChatGPT as well. But ChatGPT is actually one step worse. It appears to be better in some senses because you can ask it anything, even stuff that's not on Wikipedia, and it will generate authoritative sounding text that's often seems to be correct. But it's one step worse than Wikipedia because there's not even an author. There's no author behind it, and there's no built-in drive to tell the truth. We try to guide it along those rails to tell the truth with the training that we give it, but there's still nothing built into the engine. It's still just trying to produce plausible text. It's a plausible text generator. It generates text with no regard for whether it's true or false when it's operating on its own. And the fact that it produces true things sometimes should be no less remarkable than the fact that it produces incorrect things. And I don't think the hallucination problem is going to go away. I think where we're at right now, where people are trying to play around with more and different kinds of training to try and mitigate that problem. But I don't think it's going to go away, and I think it will end up constraining what can be done with these systems. Having said that, I mean, people are using them all over the place to do all kinds of cool stuff to help them with their work. Like as an automated assistant, it can be very helpful. There was a recent survey by GitHub, which is a coding website, that found that over 90% of working computer programmers are now using ChatGPT or tools like it, large language model tools, to help them with their coding. And I've used it myself. And it can be really, really helpful, but it needs checking. Like everything needs to be picked over and looked over by an expert. Any claims that it makes have to be checked and backed up. So it can be really helpful to get you going on a project or to help you write a piece of code that you don't have at your fingertips. But everything has to be checked and vetted. All right, so that's it. So that's how the training works. Again, my bet is that as clever as this training is, and as far as it's gotten us from streams of text that aren't that good to helpful assistant behavior, I don't think that we're eventually going to just train our way out of hallucinations. But I could be wrong, but that's my bet. Up next, we'll talk about prompt engineering. So this is really the big discovery of the system is we don't actually have to fine tune these systems to get them to do other tasks. We can just cleverly prompt them. So we'll talk a little bit about how that works for building apps out of ChatGPT, and also about how you can some strategies for you to use prompt engineering to get what you want out of ChatGPT when you're arguing with it or talking to it. And we'll maybe take another video to look at the social and ethical and cognitive implications. So anyways, I hope you're getting something out of these videos. It's fun to make them, and stay tuned, subscribe or whatever, if you're interested in hearing, in watching the next videos that are coming.